I'm going to illustrate several more key probability concepts. The most simple, these are going to work with coins just to keep things very easy. The probability of flipping 4 heads. I don't want to take 4 times 1/2. That'll get me something that's bigger than 1 or bigger than 100%. But if you think about this, you can break this down into parts. Another way about thinking, to think about getting 4 heads would be to flip heads and another heads and another heads and another heads. So that's probability of heads and multiply, probability of heads and multiply, probability of heads and probability of heads. And of course that's just 1/2 times 1/2 times 1/2 times 1/2. 2 to the 4th power is 16. There's a 1/16th chance of getting 4 heads in a row. Now, I can use that to find the probability of getting at least 1 tail. Okay? I don't want to find the probability by breaking this up into pieces, because if I find the probability of getting at least 1 tail, that could be getting 1 tail and 3 heads. It could be getting 2 tails and 2 heads, 3 tails and 1 head, or 4 tails. I'd have to add all of those up, and I don't want to do 4 probability problems. So I'm going to do this a little bit differently. I know that the opposite of getting at least 1 tail is having no tails, okay? That's called the complement of the event, okay? So I'm going to find the complement probability. The complement is no tails, which of course is really 4 heads. Well, guess what? I already did that before. There's a 1/16th chance that I have all heads, which means those other 15/16ths remaining, those all have to have at least 1 tail. So I know that the probabilities of having no tails and the probabilities of having some tails should add up to be 1. I either have to not have tails or have some. That's the only thing that I can have. It covers all possible probabilities. So I can take 1 minus the probability of the complement. Okay, in this case, the chance of having no tails is 1/16th. That means the probability of having some tails is 15/16ths. A very simple way to do problems, especially if you have to find something that involves at least a certain number of values. In my final coin example, I'm trying to find the probability of flipping 4 coins the same way. Now, this changes just a little bit because I don't specify 4 heads or 4 tails. So here are the 4 different events that I have to do. What's the probability that I'm successful the first time? Well, it doesn't matter what I flip on the first flip. So 100% of the time, I'm going to be successful on the first flip. Now, whether or not that was heads or tails, the next time there's only a 1/2 probability that I get the same thing. So success on the first one, and that I get the same thing on the second, and multiply it. There's a 1/2 chance that I'll flip that same thing on the third, and there's a 1/2 chance that I flip it on the fourth. So there's a 1/8 probability that I flip the same thing 4 times in a row. Again, that first time doesn't matter because I didn't specify whether or not they had to be heads or tails. Okay? You could do that another way. You could turn that into the probability of 4 heads or the probability of 4 tails. Okay, that would be 4 of the same thing, both possible ways. Or means that you add. This is going to be 1/16th, right? 1/2 times 1/2 times 1/2 times 1/2. This would also be 1/16th. And when you add those together, you're going to get the same exact 1/8. So there are lots of ways to do these problems. I think this is a little bit easier, but if you're more comfortable breaking it up into pieces, you're going to get the same answer.